Now we are going to discuss about a machine learning based framework for a state-wise classification of date from wide-scale disease. We are going to discuss about abstract of our project. The main objective is to identify or predict the input date palm tree is affected or not by using different machine learning algorithms. The date palm is a crop with significant socio-economic and economical importance in Morocco. It is an important crop in terms of the number of trees and distributions in the Egypt and worldwide. The disease is categorically identified so that a proper process may also begin to prevent the losses in the yield. They explore two features such as GLCM and HSV to find the most effective for date bomb classification. With the recent advances in machine learning, such as random forest and decision tree, have been successfully used for date palm disease analysis. Finally, the system can estimate some performance matrices like accuracy, precision, recall, and F1 score. So this is the flow abstract of our project. Now we are going to discuss about the flow of our project. First, we need to take a data set, date palm disease data set. The collected data is carried out to pre-processing module. Here we can resize your original size. Resize in the sense we need to give us some fixed size for all images is present in your data set. The next grayscale conversion in a sense we need to convert your RGB into grayscale format. The pre-processed data is carried out to feature extraction module. Here we can extract the features from the pre-processed data by using different techniques: GLCM, HSV, mean median variance. The extracted featured image is carried out to image splitting module. Here we can split the whole images into test and train. Test is used for prediction, train is used for evaluation. The splitted image is carried out to classification module. Here we can implement different machine learning algorithms such as decision tree, random forest. The classified data is carried out to performance analysis. Here we can estimate some performance such as accuracy, precision, recall, and F1 score. Then finally we can predict the chosen input image is affected by disease or not. This is the flow of our project. Now we are going to discuss about output of our project. We are run our project in Spider ID from another navigator. Here we can choose one input image from your dataset. So these are the date palm images. First I can choose a one input image. Yeah. This is the original image we are chosen from dataset. Then resized image, we can resize the original image. Then grayscale conversion, so just we need to convert RGB into grayscale format. Already the chosen input image is grayscale format, is just ignore that. Then the different feature extraction techniques, mean, median, variance. So these are the feature extraction for mean, median, variance. Then grade level co-occurrence matrix, that is the GLCM. So this is the result for GLCM. So this is the features of GLCM. Then HSV, huge saturation value. This is the result for that. Then data splitting. So these are the total number of images and total number of tests and total number of trained data. Next, decision tree. So with the help of this algorithm, so we can predict 99.8% accuracy. Then random forest algorithm. So the accuracy more or less same. Then identified as brownish spots. So we need to find what kind of disease. So this is the output of our project. Thank you. And finally, this is a comparison graph. Thank you.